Today we're going to go over the free response question, the day one, providing you a little bit of a different view here. You got cat sleeping in the background. Some of these plants that might look familiar. That guy is from school right there. A couple of them are from school. But, okay, so we are going to go over the free response question in this video. The other video will go over today's lecture, activity, whatever. So, get out your free response, this guy. Day one, free response question. And this was where we were looking at fruit fly behavior. In a choice chamber that's used to test whether the spatial distribution of flies is affected by the presence of a substance placed at one end of the chamber. To test the fly's preference for glucose, 60 flies are introduced in the middle of the choice chamber at the insertion point indicated by the arrow in the figure above, which I guess I did not include the figure above. That's a problem. Well, here's what it would have looked like. We actually used these choice chambers when we did our pill bug experiment. So it looks kind of like, just to refresh your memory. So you have this middle section. This is where they were dropping the flies into. And then one was soaked cotton ball with glucose. And it says one is just dry cotton. And then flies were placed here. So enter here. Okay, so that was kind of you have two different chambers. So you have this, it's going over the middle section, glucose section, and then dry cotton section. So it says to predict the distribution of flies in the chamber after just 10 minutes. And likely you guys put something like that those flies will be on the side with glucose because we use glucose and all organisms use glucose for cellular respiration. So glucose would be a food source and they're likely to be on the side with the food source rather than just the plain dry cotton. And that's because we need cell respiration to make ATP. In these free response questions, it's best to fully explain yourself. So you would want to also put why they would be on the side of the glucose. Why is glucose a food source? And that would be because of the cell respiration ATP part. So make sure you fully explain your answers on this stuff when you're prepping for the AP test. Part B, you're proposing a specific improvement for each part and give me a modification and explain how it will improve the experiment. So experimental control, their control was bad. Here's why it was bad. It's because they used a dry cotton ball, and the best possible control would be to wet it with water. So the glucose solution was diluted with water. So you would want your cotton ball to also be wet with water, but just not have glucose in it. So you'd still have the other side with glucose. So this side would still have the glucose cotton ball, but this side, instead of dry cotton ball, would be just a wet cotton ball with no glucose on it. That would be the best possible control in this scenario. And then environmental factors, you could just say, there's a variety of things you could put here, guys. You could put that you could measure temperature, humidity, light, measure those to assure that each of these sections are constants. They have an even humidity, even temperature, so that you're only measuring the factor, which is the glucose. Because that's what the key environmental variable we're focusing on is the glucose variable, the presence of glucose. Okay, so assuring that there's the same humidity and temperature, etc. Any other things you could add that I'm not thinking of, that would add to the experiment because you'd be further supporting that if there is a difference in the number of flies in the chamber, it's because of the glucose and not because of due to temperature, humidity, etc. Okay, now we get to the fun part. So now we're getting to part C. The experiment described is repeated with the ripe bananas. So one end you have ripe banana and unripe banana on the other end. So instead of glucose, this is going to be ripe banana. And then the other side would be unripe banana. And we still have our middle where the flies are going to enter there. So for ripe, we have to flip the page. Okay, so you're performing a chi-square test on the data for 10-minute time point. So we're focusing on the 10-minute time point, and we have end with ripe banana. It says after 10 minutes we have 45 flies. So that would go under observed. So we observed at the end of our experiment that 45 flies were on the right side. The middle, we observed, had 3. And then the unripe banana had 12. Okay, so those are our observed. That's directly from the table, measuring from here. So I'm looking at the time point, the 10 time point, because that's where it says to make a chi-square, using that 10-minute time point interval. And the more difficult part is figuring out the expected. So first you have to figure out what your hypothesis is going to be, okay? And that's the second part of that question on that's the second part of that question is specifying the null hypothesis. So your null hypothesis is going to be that there's no preference. The flies are showing no preference, would show no preference. They don't care if glucose is there, if there's a ripe banana or unripe banana. They don't care. They have no preference. So if flies are showing no preference, then that means that they'll probably be evenly distributed. So they won't care whether they're on the ripe side or unripe side. They'll be evenly distributed across the ripe section, the midsection, and the unripe section. So we have to figure out what that number would actually be given that. So what you would do is you'd figure out how many flies you have here. So you'd have to total your number of individuals first. Your total number of individuals would be 60. So you have 60 flies. So that means you're expected, you better also have 60 flies for expected. That's the only way it's going to work. So if you're going to have even distribution and you have 60 flies, you'd have 20. Done. Okay, so that's what we're testing. That's because our expected is our null hypothesis. And that's what our chi-square test is, our null hypothesis. So we're testing if they have a preference or not. Okay? This is what we saw. This is what we'd expect if they had no preference under our null hypothesis. So now we just have to test, all right, well, can we reject our null hypothesis, or can we not reject our null hypothesis? Okay, so that's why you have to do the chi-square. So all we're going to do is complete this table now. So I have -17, 8 of 8, 25, that's a 25, it's a bad 25, that's a 25. And then square it here, 289, 64, 625. You should not have any negatives when you're squaring because that's the purpose of it, is you're getting rid of the negatives. So none of the numbers in this column should have a negative. Then go to the next column. So 14.5, 3.2, and this one's pretty big, 31.3, and it's bigger. The bigger numbers come from a higher difference. Sorry, did my table backwards on my the one I wrote out versus here. So sorry, you're probably like, where are these numbers coming from? I had a different, I set mine up differently up here on my paper than here. So let me fix that real quick. So we have, here's our big difference here is, right, I have 25 and 625, and there's our big difference there. And that comes from a larger difference in the ripe versus from the observed expected. That's where you get these bigger numbers from. The middle, that's where you have -17, 289, and 14.5. And then unripe, here's your -8, here's your 64, and 3.2. Okay, so you're going to add these together to get your, and this would be your chi-square is the summation. Sorry, let me tilt that down a little bit. The chi-square is actually the summation of all of these. So that would end up being 49, which is that's a big number there. So when you're looking at your chi-square distribution, that is going to be way on one end. So you have, this would be your chi-square. Equals that. Okay, so now you take your chi-square number, our 49, and that's what we're going to put in the chi-square table. So now you need your chi-square distribution chart. Honestly, I'm going to attach one to this post, but you can Google it, chi-square distribution. It's always the same because the chart is the same no matter what. So if you Google one, they'll all be right. But what the number of degrees of freedom we're going to have is going to be based on the number of categories, as always. We have 3 categories here. So we're going to have a degree of freedom of 2. So if you look at your chi-square table and you find your, should have printed one off, but I didn't. You find where 49 is under degrees of freedom of 2 in that row. And you end up with a p-value that is lower than 0.01. So it's like way off the chart. So that means that if it's less than 0.05, which ours is way less than 0.05, then we can reject our null hypothesis. And this is getting into a number, letter D in here too. We can reject it because we know the variation is not due to random chance. If this p-value was above 0.05, any variation would be due from the expected, would be due to random chance. However, that's not what we see. We see a p-value of way less than 0.05. So it's not just due to random chance, meaning that we can reject our null hypothesis that that flies don't have a preference when it comes to their choice chamber given a ripe banana. So then you can make a new hypothesis you can further hypothesize after that if you're going to do another experiment, say, and I'm on D now, that flies do have a preference of chamber. We figured that out with this experiment. But our next hypothesis, we could say that this would be due to glucose availability. We still don't know whether it's for sure due to glucose, but we do know that they prefer this side, the right side of the choice chamber, and that's what we have statistically supported with our experiment. Okay, so if you guys have any questions about this, shoot me an email. Otherwise, have a wonderful day. And our next, we're going to set up a Hardy-Weinberg. I'm going to do this with Hardy-Weinberg problems for our next free response, and that'll be attached to here. So you guys enjoy the sunshine that's going to come out in the next couple days. See you later.